Hello and welcome to a new video on IGCSE Physics Classified Paper 4. In this video, we shall be discussing the topic of electric charges. In this question, we're told figure 10.2 shows two uncharged conducting spheres suspended on insulating threads. The spheres are now both given positive charges. On figure 10.2, draw a possible position of each sphere and thread, and explain the positions you have drawn. So if both spheres are given positive charges, then these spheres are going to repel from each other. They're going to move away from each other. And the reason for this is because like charges repel. So since like charges repel, we expect the spheres to move away from each other. This is what the drawing should look like. In this question, we're told figure 8.1 shows a polystyrene ball covered with aluminum paint. The polystyrene ball is suspended between two charged metal plates by an insulated thread. And we're given the diagram that shows this. We are then told the ball oscillates between the two charged plates. Explain why the ball oscillates. So here's the idea of what happens. First of all, the ball is going to hit the negatively charged plate. And then when it hits the negatively charged plate, it becomes negatively charged because it acquires electrons. And then once it acquires the electrons, it is repelled by the negatively charged plate and attracted to the positively charged plate. So at the beginning, it's going to move in this direction, for example. And then once it hits the negatively charged plate, electrons are going to flow to the ball itself. So it's going to become negatively charged. Now, since the plate is negatively charged and the ball is negatively charged, the ball is going to be repelled and is going to move in this direction until it reaches the positively charged plate. Now, once it reaches the positively charged plate, the electrons, the excess electrons that are on the sphere or the ball, are going to transfer to the plate because it's positively charged. So the electrons are going to leave the ball and move to the plate until the ball itself becomes positively charged. Now, once the ball is positively charged and the plate is already positively charged as well, these are going to repel, and therefore the ball will move to the right again and will be attracted by the negatively charged plate. Once it goes to the negatively charged plate, we repeat the cycle again. It becomes negatively charged and then repels and then goes to the positively charged plate and so on and so forth. Figure 8.1 shows a positively charged cube of insulating material. The cube is fixed to a piece of wood that is floating on water. A negatively charged rod is held above the piece of wood and brought close to the cube as shown. State and explain any movement of the piece of wood. Now, we have a piece of wood, and we have a positive charge here and a negative charge here. So we expect that the piece of wood is going to move to the right as such, because these are opposite charges and they attract each other. Bear in mind that the rod is fixed in position. Somebody is holding the rod with their hand. They're fixing it in position. But the piece of wood is floating on water, so it's free to move. So therefore, the piece of wood is going to move to the right until the positively charged cube is stuck to the negatively charged rod. They're attracted together and they are stuck. So the cube is going to shift to the right and move somewhere here like this, and is going to be in contact with the negatively charged rod. So all we have to say here is that the piece of wood is going to move towards the negatively charged rod, and the reason is that unlike charges or opposite charges attract. In the second figure, we are shown two cubes of insulating material. One is positively charged and the other is negatively charged. As you can see, the cubes here One of them is positively charged and the other is negatively charged. And the cubes are fixed to a piece of wood that is floating on water. So the piece of wood itself, the circular piece of wood, is free to move. It's floating on water. Then charged rods are held above the piece of wood. So these rods that are in blue circles, these are fixed in position. They are held by hand, for example, so that they are not allowed to move. And they are brought close to the cubes, and we want to know what happens. So in this case, the piece of wood experiences two forces, a force in this direction here, and another force in this direction here, because the positively charged cube wants to move towards the negatively charged rod, and the negatively charged cube wants to move towards the positively charged rod. So we have two forces acting in these directions, and this produces what we call a couple. So when we have two forces acting in these opposite directions, they produce a moment. And since they're two forces, we call them a couple. And you can tell that the moment here in both cases is moving in the anti-clockwise direction. So since the two forces produce anti-clockwise moments, we expect that the piece of wood is going to rotate in the anti-clockwise direction, since the two forces produce a couple or a torque. An uncharged conducting metal plate rests on insulating supports. Figure 10.1 shows the plate and a positively charged insulating plastic sheet placed on top of the metal plate. Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. So first of all, let's go back to the question so that you're not confused. First of all, the negative charges on the metal plate, there are negative charges and positive charges, because this is a metal plate and it has an equal number of negative charges and positive charges. So at the beginning, what is going to happen? The negative charges are going to move towards the top because they are attracted to the plastic sheet. So therefore, we're going to say that the electrons or the negative charges move towards the top of the metal plate. In double I, we are required to draw how the charges are now arranged after the movement of the negative charges. Of course, we don't expect all the negative charges to move up and all the positive charges to move down. This is unreasonable. But we expect that most of the negative charges will be positioned up and most of the positive charges will be positioned down. So to draw a reasonable arrangement of charges, you would draw the majority of negative charges in the upper layer and the majority of the positive charges in the lower layer. So therefore, you can see here that we have 5 negative charges on top and 2 negative charges at the bottom. And we have 5 positive charges at the bottom and 2 positive charges on top. And you need to have the same number of positive and negative charges in total. So we have 7 here and 7 here. So we have a total of 7 positives and 7 negatives. State and explain if this arrangement of charge helps to keep the plastic sheet in place. We must say that this arrangement does indeed help to keep the plastic sheet in place because the majority of the top charges are negative and the plastic sheet is positively charged, as we were told. So the negative charges and the positive charges attract to each other and the plastic sheet remains in place. A similar event occurs when we have a ceiling of a room like this. We have a balloon that floats up until it reaches the ceiling. The same exact event occurs. So if the ceiling, for example, is negatively charged, the electrons are going to move down, they will be repelled, and the positive charges are going to dominate the upper layer of the balloon. And then there is an attraction between the positive and negative charges here, which is why the balloon keeps stuck to the ceiling. So this is another question that might come up. It's a similar arrangement to this one. Because the opposite charges are in close contact like this, the balloon is stuck to the ceiling. And this is the same case as what happened here. So we're going to say that at the top, electrons are greater in number, and they are attracted to the positively charged plastic sheet, therefore keeping the plastic sheet in place. Next, we move on to questions that relate to what we call the conducting sphere. In A, we're told, describe the movement of charge that causes an object to become positively charged. So any neutral object has the same number of positive and negative charges. And we should know that positive charges are heavy, relatively heavy. They are heavier than negative charges, and they are less likely to move. So the charges that are more likely to move are electrons or negative charges. So when we're talking about movement of charge, we should always note that the negative charges are the ones that move. So when something is positively charged, this is because of a loss of electrons, not a gain of protons or positive charges. Because the negative charges are the ones that are lighter and more agile. They're the ones that are more likely to move. So in order to become positively charged, the body must lose electrons. So therefore, we can say movement of electrons from the object to another object or loss of electrons by the object. In B, we are told figure 10.1 shows a negatively charged rod held over an uncharged metal sphere. On figure 10.1, add positive and negative signs to represent the results of the movement of charge within the sphere. So this is similar to a previous question that we solved in this video. We said that the positive charges are going to be concentrated at the top and the negative charges are going to be concentrated at the bottom. And you should draw an equal number of positive and negative charges. Describe the actions that must be taken to obtain an even distribution of positive charge on the surface of the sphere. So in this case, we have a concentration of positive charges at the top. We want the sphere to have an even distribution of positive charges. So how would we be able to do that? So the way to do this is to first connect the sphere to Earth. What does that mean? By connecting a wire from the sphere to the Earth, a conducting wire to the Earth, the electrons are going to flow out of the sphere and into the Earth. And then we remove the Earth wire, and after that, we remove the negatively charged rod. So after removing the Earth wire and removing the negatively charged rod, we're going to get a sphere that looks like this with an even distribution of positive charges. By even distribution, we mean that the positives are not concentrated at the top like this. They are distributed all over the sphere. In order to do that, we connect an Earth wire to get rid of the electrons, and then we remove the Earth wire that we connected, and finally, we remove the charged rod. And as you are going to see in this video, this question is often repeated in exams. We're going to meet it once or twice again. And you should know this procedure of getting an even distribution of positive charges on the sphere. A metal sphere mounted on an insulating plastic stand is positively charged. State the name of the unit in which electric charge is measured. So you should know that electric charge is measured in coulombs. In B, we are told a smaller metal sphere also mounted on an insulating plastic stand is uncharged. So the big sphere is positively charged and the small sphere is uncharged. The smaller sphere is moved close to the positively charged sphere. Figure 8.1 shows the two spheres. In I, we are asked to draw the distribution of charge on the smaller sphere. So since this is positively charged, we expect the negatives to be shifted towards the left, towards the other sphere, and we expect the positives to be shifted towards the right, away from the bigger sphere. In double I, we are told an earthed metal wire is touched against the smaller sphere. State and explain what happens to the charge on the smaller sphere. So we said that as soon as we connect an earth wire to a charged sphere, the electrons flow through the wire from the Earth into the sphere. So this is slightly different from what we said in the last one. In the last one, we said that the electrons are going to flow outside of the sphere. But the difference here is that the positive charges on the sphere are concentrated towards the right. And the negative charges are concentrated or attracted to the positively charged sphere. So the electrons here do not want to move. They are stuck on the left because they want to be attracted to the positive charges here. So when we connect an earth wire, seeing that there is a concentration of positive charges here, the electrons are going to move into the sphere through the earth. So from the earth through the wire, the electrons are going to move into the sphere. And then since we originally had an equal number of positive and negative charges, we had 3 negatives and 3 positives, and now we had more electrons coming up into the sphere. So the new result is going to be a sphere that has, for example, 3 positives and maybe 5 or 6 negatives. Since we added some extra electrons coming up from the Earth, so therefore the sphere is going to become negatively charged. So you must note when the electrons are going to leave the sphere and go to the Earth, and when the electrons are going to move from the Earth to the sphere. What decides this is the charge on the other sphere. So here, because it's positively charged, the electrons are going to remain in position. They're going to remain attracted to these positive charges, and new electrons are going to move from the Earth into the sphere. However, had the bigger sphere been negatively charged, the arrangement would have been different because the electrons were going to be repelled. The electrons would be here and the positives would be here. And if we connect an earth wire, the electrons would be likely or willing to escape from the sphere into the earth. So the movement will be out of the sphere in this case. So what determines whether the electrons are moving out of the sphere or into the sphere is the charge on the other sphere. A smaller uncharged metal sphere S is suspended by a plastic thread and brought close to the negatively charged sphere. The figure shows the two spheres. By drawing on figure 5.2, indicate the distribution of charge on S and state what happens to S. So in this case, because this big sphere is negatively charged, we expect positives to shift to the left and negatives to shift to the right. And the sphere, the small sphere, will get attracted to the large sphere. Now we're going to use an earth wire again, and we're going to touch the small sphere. So what do we expect here? Do we expect the electrons to move into the sphere or out of the sphere? So in this case, since we have negative charges here, we said that the electrons are repelled and they are trying to escape from the sphere. So as soon as we connect an earth wire, in this case, the electrons will move out of the sphere and into the earth because they are repelled by the negative charges here. So this is the difference between the two cases. And since they are going to move out, we expect that S is going to become positively charged because instead of having 3 positives and 3 negatives, after the electrons here move into the earth, we expect S to have more positives than negatives. So maybe like 3 positives and 1 negative. So therefore, the sphere S is going to be positively charged. Figure 8.1 shows an uncharged conducting sphere on an insulating stand placed close to a positively charged rod. The rod and the sphere are not moved. Describe how to charge the sphere using a wire connected to the earth and explain whether the sphere becomes positively charged or negatively charged. So in this case, we have a positively charged rod. So we expect the negatives to be attracted to the rod. We expect the positives to be repelled. So when we put an earth wire here, we expect electrons to flow into the sphere. We expect the negatives to flow into the sphere, and this will result in having more negatives than positives. So we had 3 negatives and 3 positives initially, and now electrons are going to flow into the sphere. So now we have 6 negatives, for example, and 3 positives. We have more negative than positive. So we expect it to become negatively charged. So how do we charge the sphere? First, we earth the sphere. What does the expression earth the sphere mean? Earthing the sphere means that we connect a wire to the earth, this red wire here. Of course, red is just the color I'm using. It's not actually red in reality. But this wire here connects the sphere to the earth. And the direction of motion of the charges depends on the arrangement. So here we have more positives because the negatives are attracted here. So therefore, we have more positives on the other side. And therefore, the electrons are going to flow into the sphere. So electrons will move into the sphere from the Earth. And then after we remove the Earth wire while holding the positively charged rod. So this is also very important, the sequence of steps. So first we attach the Earth wire. We earth the sphere. So the first thing we do is we attach an Earth wire to the sphere. And then the electrons will move into the sphere, like we said. And then we remove the Earth wire while holding the positively charged rod close by. So why is this important? Because if we remove the positively charged rod, then this idea of having electrons on the left and protons on the right will no longer hold. So if this does not exist, then and we connect an earth wire, then these electrons will be free to move through the earth wire. So the idea here is to maintain this positively charged rod in position and connect the earth wire first so that the negatives flow into the sphere, since these negatives are on the left and these positives are on the right. And then after connecting the earth wire, we remove the earth wire while this is in position. So after we remove the earth wire, the electrons are now more than the protons. Then we can remove the positively charged rod, and we can tell that it will become negatively charged. For the final question in this video, we are told a conducting sphere is mounted on an insulating stand. Explain how you would use a positively charged rod of insulating material to charge the sphere by induction. So this is a repetition of the question that we just did. Again, we said that we have a sphere and we have a positively charged rod here. So we're going to approach the positively charged rod. The negatives will move to the left, the positives will move to the right, and then we earth the sphere. Now we have electrons moving in from the earth. And then we have to remove the earth wire while keeping the positively charged rod in position. But now we have more negatives than positives. So after removing the earth wire, we can then remove the rod, and we will have a sphere that has more negatives than positives, and it will be overall negatively charged. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.